So you want me to repeat once more, or someone can tell me what happens from the first light ray, second light ray, third light ray to the fourth light ray? It's better you speak, I can direct you what's going wrong in that. Don't mind what's happening from your side, right or wrong. If you can't tell me, no issues in that.
So in the first case,
yeah,
it's falling along the normal, so it's just going to, it's not going to refract, it's going to continue in the path and go straight.
Yeah.
In the second case, there's an incident angle, it's not zero anymore. But then since it's going from denser to rarer, the refracted angle will be greater than the incident angle.
Correct.
And then further,
it will go on for so many light rays with I greater, R also greater, finally.
Yeah, finally there's a point where R reaches 90 degrees. And so for that, the incident angle is called critical angle.
Yes, that's the definition for critical angle even, okay? That particular angle of incidence for which the angle of refraction becomes
90.
Then what happens after that?
After that, I becomes greater than C, which means R becomes greater than 90. So it doesn't refract to the next medium, it just reflects internally. And it's known as total internal reflection.
Yeah, it's called total internal reflection because complete light is reflected, even not a single light ray going to the other medium.
Okay.
So, what are the conditions for total internal reflection?
I is greater than C.
And R is greater than 90.
Okay, I is greater than C automatically will come as what? R greater than 90. Don't worry about that.
Okay. And light must travel from a denser to rarer medium.
Why don't it happen from rarer to denser?
Because then
it's the correct answer you told. I just want a justification, that's it. If you say, then I don't want to tell you, right?
Because when you go from a rarer to denser medium, the R wouldn't be greater than I, right? It will be less than I.
You can see the first second light ray, it's bending away from the normal, right?
Yes, sir.
Yes, sir.
Because of that only R is greater than I.
Yeah, but then in the other case, it would bend toward the normal.
Yeah. So even I become 90, R will be always less than 90 only. Yes?
Yes.
When light is traveling from rarer to denser, light ray bend towards a normal, reducing the angle of refraction compared to the angle of incidence.
Yes, sir.
So there is no possibility for total internal reflection to happen when light travel from rarer to denser. It happens only when light travel from denser to rarer, but not always. Only when I is greater than C.
Yes, sir.
Yes, sir. Okay.
So the two conditions are light must travel from denser to rarer with angle of incidence greater than the critical angle.
Yes, sir.
Are you fine with the concept? What do you mean by total internal reflection?
Yes, sir.
It's a case where,
What if I is equal to 180 degrees?
I is equal to 180 degree. How you get I equal to 180 degree? Which case?
I don't know. I was just thinking of angles and I thought of
You can have I maximum 90 degree only.
Okay.
Because see, this light ray will go like this. Now is what? Maybe 70, right?
Yeah.
If I take another light ray from here, this. If I take another light ray from here, this will have maybe 80 degree. This may be 60 degree. This is the one which have a 90 degree because the normal will be. So there's no possibility of angle of incidence to be more than 90. Fine?
Yeah.
Sir?
Yeah.
Anusha's not added yet to this.
Okay. Right.
She says she got the invitation, but she can't add on to it.
No, she can join. No, I'm just inviting her.
She said she couldn't do it, so yeah. Okay.
Okay. So the two conditions are light must travel from denser to rarer with angle of incidence greater than the critical angle. So there is no possibility of angle of incidence to be more than 90. Fine?
Yeah.
Yeah.
Sir?
Okay. I'm calling again. So I think this is fine.
Yes, sir.
Yes,
Yes,
You
sir.
should know the ray diagram. You should know what happens. You should be able to define critical angles. You should be able to define state the condition for total internal reflection. Can you apply Snell's law for this particular case? R equal to 90. R equal to 90 case is known as just TIR. Okay, it is not TIR, just TIR. It's going to happen like that. Can you apply Snell's law in that case? Sin I by, you're already there on the top. You can tell me sin I by sin R is n2 by n1.
So sin
What's I?
I by is
Hello?
C. So sin C.
Yeah. I sent 2-3 times invite also. Okay. I just see once more. Actually, my name is already there in this. I don't know. Yeah, I'll check once more. I'm sending one more time. Okay, just check my phone. Don't. Okay. No, I'm going to send one more time. Okay, fine. Yeah, it's fine. I want the values for I and R for this particular case. When I equal to C, it will come sin.
C
Yeah. By
by sin
Sin
90,
90.
which is 1.
1 equal to,
N2 by N1.
yeah, check which is second medium and first medium.
Air by,
Second is air. First is
yeah,
Okay, I want
air
rarer
by
denser, not air and water. It won't be always air
rarer
and
by
water.
dense.
rarer by
Rarer by
denser.
denser.
N
Rarer
rare by N dense.
and denser. Okay, imagine second medium is air. So air, the refractiveness is
1.3.
and how the formula get modified.
What?
So sin C equals to 1 by D.
1 by
ND, sorry.
it's fine.
Yes, sir.
Okay, now if this point you take as O as an object, like a person, or you keep a bulb here. It's a bulb. So from the bulb you can see the light ray coming out, right?
Yes.
Yeah, so
This light ray will come out here. Till this light ray will come out. Which point? Can you see the cursor?
Yes.
Yes, sir.
yes, sir.
Till that light come out. What about the light ray coming after that point?
It won't.
It'll get
It'll
reflected.
get internally reflected.
Okay. So this will happen for the left hand side also, not only for the right hand side. Till here the light will come out. From here the light will not come out. After that, sorry.
Yes.
So this will not happen on left and right. It happen on front and back.
Okay.
That means it will be a circle of light rays coming out like. Will you get it?
No, sir.
No, sir.
So did you get left and right?
Yes, sir.
Yes, sir.
So it's a solid medium, 3-dimensional medium.
Yes.
So do you have a pencil with you? One pencil.
Yes.
sir.
Yeah.
You keep the pencil straight up like this particular way, right?
Yes, sir.
Yes. And I'm keeping the pen till this one, like the one happening just here. It will be forming an angle, right?
Yes.
Yes,
That
sir.
will happen on the left hand side.
Yeah.
That will happen on the front. That will happen on the back. So it will be like a cone.
Yes.
Oh, okay.
Fine.
Yes, sir.
Yes, sir.
So the light only comes through this circular area.
Okay.
Beyond that, the complete light will be reflected down to the denser medium.
Yes, sir.
Fine.
Yes.
Yes, sir.
So if we cover the top of this circular area by a disc of cardboard, no light will come out from the water. Even the other part is transparent. So if you want to find, are you okay with the disc shape and the light coming out from what area?
Yes,
Yes,
sir.
sir.
So this is a normal question asked for the boards. Find out the area through which light can emerge out. How to find the area? Area normal formula for a circle is
Pi r
Pi r
square.
square.
I don't have an option for square and also square. So how to find R? What is R? This is O. I mark this point as A. This point as B. So AB will be the
Radius.
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 So what is this angle called?
Critical.
Critical angle. So what about this angle then? The alternate interior angle, like
Yeah,
this angle,
so critical angle.
till here. This one, this
Okay.
angle. What is the angle this? It's an alternate interior angle, like.
Oh,
Yes, sir.
Okay. What is this angle? This angle, left hand side, this angle. That's C. You can find.
so which angle again?
You know this light ray I'm marking now. Can you see this paint?
Yes,
Yes,
sir.
Yes.
The one going to the left. Yes.
Yes.
It makes an angle with the normal here. What is that angle? This angle basically.
Critical angle?
Yeah, same no. Then only it become parallel, right, from here.
Yeah.
Right, it will go parallel because of it just falling at critical angle, right?
Yes.
Yeah.
So this angle will be,
Critical angle.
yeah. See, confusion, you tell me if you're okay, fine. This is C. And what about this angle then?
C.
C.
Is it fine?
Yes,
Yes.
sir.
Yes, sir.
This line and this line are parallel.
Parallel.
This is a transversal. So this angle, are you fine or I'll go another way?
It's fine, sir.
It's fine.
If this is 30 degree, what will be this angle?
90 minus 30.
60.
60.
This is 90 already, right?
Yes, sir.
What about this angle?
30.
So this is same as this one, right?
Yeah.
Yes.
So if you apply tan C, what will happen? Tan C. My aim is to find R. Tan C. Tan C.
So,
Opposite side by.
so
See
So,
A.
A.
This is
AC by AO.
this
AO.
AB same as that, no? This distance is same as that. Like
So AB by AO.
AB by AO.
I can write R, no? Radius directly.
R by
R by AO.
Okay, I'm giving this as H. What is H?
R by
R by H.
H is the height of the medium. Okay, complete. So tan C will be
R by
R by H.
H I can take left, right?
Yeah.
Fine.
Yeah.
Yeah.
Sure. If I substitute this back here, I get the area. For that, H must be given, C must be given. Where you lost the connection, can you tell me?
Just a minute. Let us process it.
Sorry, I can't hear. All are there on the other side, or
Yes.
There's
sir.
where here, sir.
okay? That's what
So
I
we
asked.
can
If
use the right side itself, right?
yeah, both sides the same, no different.
Okay.
Why didn't I use right hand side? There are so many light rays. No, you get confused which angle I'm telling.
Okay. Okay.
Is it fine, or?
Yes, sir.
Okay. If C is given, you can do. Sometimes they won't give C. They will give refractive index. Then what do you do?
Snell's law.
No, we already have here sin C equal to 1 by ND, right?
Yeah.
Yeah.
Yeah. Is
So-
equal to the refract, so you can find C.
Yeah. Sin C equal to, I'm putting 1 by N, not D. Fine, right? Only 1.
Yeah.
What about cos C then? Cos C, you don't want to find any table.
Is equal to
What will
N.
be cos C? Cos theta is root of 1 minus sin square theta.
Root of 1 minus.
Can you write in your sheet, because I can't write root and all in this. What is sin C? 1 by N. What about cos C?
The root of 1 minus 1 by N.
And
Take LCM.
N minus 1 by.
N square minus 1 by N square whole root, right?
Yes, sir.
Okay, find tan C from that. How we find tan C?
Sin by cos.
Yeah, sin by cos. See what comes? Sin C is already 1 by N. Cos C will be,
Root 1 minus
yeah,
sin square c. So tan will be 1 by nd bracket root of 1 minus sin square c.
ND you leave, just put N.
Okay.
Easy to write.
So
Root of N square is N, right?
Yeah.
So that N get cut cancelled.
Gets cancelled. So 1 by.
1 by n square minus 1.
Yeah, 1 by root of N square minus 1.
Yeah.
Yes.
Now substitute that back into the R formula. What is R then?
H tan C.
Yeah, H tan C will be.
1 by root of n square minus 1.
Now go back that with the area, pi R square.
Pi h square by n square minus 1.
Yeah, that's the formula for the area. So you only want to know what all things.
The angle C and H.
Now C you don't want even.
No.
Now we change C, no?
Yeah.
If C is there, fine, it's very easy.
Yeah.
Directly you can find using this formula. Sometimes they will not give C, they will give N.
Okay. Yeah.
So this is the topic, what is a total internal reflection? And one application I told you, now you can find the area through which light comes out. It's a normal question asked for the exam. It is there in the worksheet what's uploaded. Okay, I'll discuss one more question as an application. Or you tell me which point is not clear to you. I'll come back. Anyone sleeping? It's a good time to sleep after food.
No, sir.
If you try to speak to me, you won't sleep, okay? Otherwise, there may be possibility.
So what's the final answer that you get for the area?
What I got is 5 times of h square divided by n square minus 1.
Okay, sir.
You got it?
Yeah.
Okay. And questions maybe they will give the values, okay? I didn't give any values. I just did in terms of variables, h and n. They can give you 80 centimeter depth of the medium with water of refractive index 1.33. So it give the values directly into that, okay?
Yes, sir.
If you're okay, tell me, sir, you can proceed to the next one. Otherwise, I'm waiting for your response.
So you can proceed.
So you can proceed.
The 17th question next one. I'll just show you the 17th question paint.
So you can continue.
Yeah. It's another question. It's asked for the board 3-4 times.
Yes, sir.
Yes, sir.
So, can you tell me what are the possibilities of light traveling from a denser medium to rarer medium? How many possibilities? Number 1.
3.
Yeah.
3.
What are the 3 possibilities?
First, it can fall on the normal, the incident
Yes,
light,
correct.
so it can
Okay.
refract. Second, angle of refraction is less than 90, so it'll refract.
Okay.
And then the third, critical, so total internal.
That's it. One more case is there, no?
So 4. Yeah. One is reflection.
You told me normal. You told me R is less than 90. You told me R equal to 90. R greater than 90 also.
Yeah.
Yeah, one more case. So 4 cases.
4.
What about rarer to denser?
1. No.
2.
Yeah.
2.
Yeah. So going straight with normal. Otherwise, it will bend
Towards
The normal.
towards normal. So rarer to denser is easy to understand and discuss, but denser to rarer you have to be careful.
Yeah.
Get check all the 4 possibilities. Okay.
Yes, sir.
Okay. This question, what is here in the paint? It is showing 3 colors: red, green, blue. You're seeing, right?
Yeah.
Yes, sir.
It's a right-angled isosceles prism. If you see, isosceles face of a right-angled isosceles prism. Okay. So this angle will be
90.
90. This angle is supposed to be
40.
45.
this also
45.
45. So I don't know, I can type on this. Okay, I'm giving this as A. The down lowermost point is B, and the right extreme point is C. So what happened to the light ray falling on AB? AB. You learned now 4 cases. Is it that case or this is a other different case? This is from which medium to which medium?
Rarer to denser.
Denser.
Okay. How the light rays are falling?
It's for a normal.
Yeah.
To the
So
normal.
what's the angle of incidence?
0.
Angle of refraction.
0.
0.
What happened to the light ray?
It just
It
It
just
just
passes.
passes.
Light rays go straight, right?
Yes.
Where? If I draw the light ray, the light ray will go straight from here till this. Why? Because after that there's another medium again. Now at AC, what will happen?
It's from denser to rarer.
Yeah. So what all possibilities for it? There are 4 possibilities.
Yeah.
Is the first possibility possible in that?
No.
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 First possibility is possible only when the light is falling normal, like this, 90 degree. Right?
Yeah.
Yes, sir.
So first possibility is not possible. Then what's the next 3 possibilities? I should be less than C, I should be greater than C, or I equal to C, right?
Yes.
So you should know I, C, then only you can say what will happen. Yes?
What type of?
Yeah, out of the 3, what will happen? What type of total internal reflection or refraction, what will happen? You should know I and C.
Yes.
So I'm finding I and C first, okay? So I'm drawing a normal here. What do you call angle of incidence? I'm only connecting blue light ray, the rest we'll discuss later. Blue, now this blue. Which angle is angle of incidence? Between the
Normal.
And the blue ray.
incident ray and the
Normal.
normal. So this is the angle of incidence, right?
Yes.
Angle of incidence. So how much that angle?
I.
Yeah, value. This is 90, this is 45, this is 45.
Oh.
Yeah, what about this angle? This angle?
90.
90.
What about the top angle?
All 90.
90.
No, top, this top angle, this
Oh,
one.
45.
45.
Yeah, then what about this angle?
40.
45.
Yeah, this is 90, this is
Yeah.
45. This can be big triangle, right?
Yeah, 45.
It's 45. What about the total angle of this normal?
90.
90. So this is 45.
45.
So I has to be
45.
45. So you got I, right?
Yeah.
What's the condition for total internal reflection? For TIR, I should be
Greater than
greater than
C.
C. There are different methods. This is an easy method I'm going without any log table, okay?
Okay, sir.
Take sine on both sides. What will happen? Sine.
Gets cancelled.
Sin
Sin I
is greater than sin C.
and C, right?
Yes.
The I value
40.
45. So sine 45 I can write, right?
1 by root 2.
1 by root 2, right?
Yes.
1
Yes.
divided by
Root
root of 2. They should give an option for using paint with the root and all. Okay. What is sine C?
1
Sin C.
by n.
Yeah, we learned one result in the previous case.
1 by n.
1 by n,
1
right?
by n.
So if I take, oh, this I put equal to that wrong. Should be greater. If you take reciprocal of this, what will happen?
Root 2
is
is
greater
greater
than
than
is
n.
equal to n.
2 is what? 1.414, right?
Yes.
Yeah.
1.414 should be
Greater. Oh.
less than, no?
Less than.
When you take a reciprocal,
Yeah, it changes.
sure, 2 is less than 4. Take the reciprocal. 1 by 2, 0.5. 1 by 4, 0.25. It should be greater. The sign will change, right?
Yes, sir.
So equal to n. Not equal to, less than n. Is it fine with you?
Yes, sir.
Now check the n for different colors given in the question. N of red is 1.39. Is it satisfying this? Is it 1.39 greater than 1.414?
No.
No. So for red, what will happen? Red will not undergo TIR.
No.
It will?
Undergo refraction.
Yeah, correct. Red will refract away from the normal, right?
Yeah.
Right? Denser to rarer.
Rarer.
Away from normal. What about the other two colors? Can you check?
It is true.
What about green? 1.44.
Greater.
1.49.
Oh,
They both are
Greater.
greater.
Green and blue undergo total internal reflection. So if I draw the light ray,
Is 1.414 the critical angle?
1.414 is, I told you I'm taking the root inverse, root of 2.
Yes.
Root of 2, what's the value? Square root of 2.
1.414.
Yeah. The 1.414 is the refractive index corresponding to that.
Yes, sir.
Is it okay, or you can go another way, but that's little long. Yet log table, yet find the critical angle for each color.
sir, it's fine.
So it is okay.
This is fine.
Okay, then how the diagram will come? The red will go bending away, right?
Yes.
Yeah.
Yes, sir.
It won't go straight. It will bend away from the normal. This is the red, and this will be the normal if you draw here. And what about the green and blue? They will undergo
Internal.
Total internal.
Total internal refraction.
reflection.
Oh.
So
Reflection.
if I is 45, R also will be 45, right?
Yes.
So total angle will be 90 then. So the light ray will come like this, 90. Yes.
Yes,
Yes,
sir.
sir.
What will be the angle of incidence on BC? What will happen on BC?
I'll go straight.
To go straight. Because it's falling normal, right?
Yes, sir.
Even I should say what happens at C, okay? Not C, at BC.
Okay.
BC I equal to 0 or equal to 0. Light goes straight. This is simply an application of the TIR we have done topic.
Yes, sir. So this is a 2 marker?
This is a 3 marker.
Okay.
Even 1 year board asked, giving the second value is 1.414. Then what do you do?
Yeah.
Then
Then-
I
Then it'll go along is.
go along AC.
Yeah, correct. Because both are equal, right? Exactly that case. I'm waiting for your response.
Yeah.
That
So we can
confusion,
proceed.
this confusion, that point is not clear.
No, sir.
Okay, then there's another question. If the same thing happens on an equilateral prism, what will happen? For an equilateral prism means all the 3 angles will be
60.
60.
60. And all the light rays are falling normal on one of the face. The light rays are falling normal on this. There are 3 light rays falling 90 degree on this. What will happen at AB?
It will not refract.
It's normal, okay?
Yes, sir.
Falling normal. So at AB, what will happen?
It will go straight.
Straight. So I'm taking the last light ray, okay? The last one, easy to draw for me.
Yes, sir.
To go straight. Okay. So this explanation is same for the first part, right?
Yes.
First part is
Yes,
same.
sir.
Then what happens at AC?
We have to find I and C and then
Yes. First find I, like the last case we had done. To find I, we need a normal. So what is this angle? 60. What about this angle?
90.
90. And what about this angle?
90. No, wait.
This angle.
30.
no.
30.
30?
30.
For that it has to. Okay.
Yes. Divya.
30?
No, okay. I think the figure there's a little mistake because it would bisect. Then it'd be 30, right? Oh wait, never mind. The triangle is there.
Okay, maybe my diagram is slightly different, but this is a right 90-degree point. Okay, it's intersecting is like straight, normal.
Okay.
This will be 90. That is 90, and this has to be what?
30.
30.
30. Our angle of incidence will be
60.
30.
30.
60, right?
60.
How?
Because
This is normal, right?
Yes, sir.
Okay, yeah, so 90
This
degrees.
Okay,
total,
that will be 90.
total angle has to be 90, right?
Yes, sir. Got it.
Fine.
Yes, sir.
Yes.
And what change will happen here? Can you check and tell me?
where?
No, here it's I is different, right? Angle is changed now.
Okay.
So for TAR, what should happen?
Sin I should be greater than sin C.
Yeah. So for TIR, I should be greater than C.
C.
Yeah. Then I can do directly. I don't want to do sine, right? Separate. I understood now. Yes.
Yes, sir.
Sin I, sin C. Now go to the next step. What is sin I and sin C? What is sin I? Sin
60.
sin 60 is
Root 3
Root
by
3 by
1 by
2.
root 3 by 2. So root of 3 by 2 should be greater than
I see.
sin C is 1 by n, right?
Yes, sir.
Yes, sir.
Okay. You take the reciprocal, it will come.
Root
2
2
by
by
root 3
3
is bigger than, no, is less than n.
n.
Yeah.
So I'm finding 2 by root 3. Calculator, okay?
1.15.
Correct?
Yeah.
Yes, sir.
1.15. So 1.15 is what's it?
Less than
Less
Less
than
than n.
n. Now check each case. Now go back and check each case. Red, blue, green, all.
all of them will undergo TIR.
TIR.
So all colors undergo TAR. Answer will not be same like what you done. The method is same, okay? You have to check the rule. That is better now.
Okay, sir.
Now how to draw the diagram. If I draw this light ray straight here, this one, and one normal, because the last one is hard to draw for me, that's why. What is the angle of incidence?
30.
30.
No.
No.
60.
60, yeah.
60. So what about angle of reflection again?
60.
60.
It has to be 60, right?
Yeah.
Yes, sir.
That diagram is not okay for me. I can't draw on that, okay? Drawing another diagram. You want to take another page or it's fine? You want to do the diagram in a different page?
No, so it's
No, sir, it is fine.
Now this is the first light ray falling here. Here. The normal. So what should be the angle for the reflected light ray then?
60.
60 degrees.
60. So which angle should be 60? This is 60. Yes.
Yes, sir.
This angle has to be 60. This angle also has to be
60.
What about the other small angle on the right hand side? This
That's
small angle.
30. 30.
30.
This already what angle?
60.
60. What about this angle then? Has to be.
90.
90.
90.
Go straight down. So all the three colors will go straight down. Okay.
Okay.
Yes, sir.
So if I draw down here, now this one, I should draw up. Okay, from here. So better you make all the light rays fall on the same side.
Okay.
So can they ask like a rectangle or a pentagon or I don't know, more complicated shapes?
They will ask you normally rectangle. They can ask you rectangle with a different angle. The same you can find the angle in rectangle. Same way.
Okay, sir.
For a case like this is fine with you?
Yes, sir.
So this case last one diagram was fine, or you want me to draw it again?
No, sir.
No, sir, it is
it's
fine.
Okay, so
So if it's a glass slab like this, the light comes here. If it's normal, it won't happen for a glass slab, right? Why? What happened to the normal one?
It'll pass straight.
It goes straight. If it's not normal, it comes here. Then this is the normal. They should give you the angle of incidence. Divya.
Yes, sir.
Then after that, it will undergo refraction, right?
Fraction.
Yes.
So it undergo refraction like this. Using Snell's law, here to find the angle of refraction here. This angle should be given to you. You will have refractive index. After you find that angle, these two angles should be same, right?
Yes.
Yes.
Yes, sir.
From that, you can decide whether to undergo TIR or refracted.
Okay.
Okay.
If you're fine, I'm going for the next topic. Otherwise, I'm waiting for you.
Fine.
That's fine.
It's fine, sir.
So these two are very important applications what we discussed so far. Normally ask for the exams also every year, most of the years, right?
Okay, sir.
There are few normal applications what we see as like writing part, optical fiber.
Okay.
Yeah. Diamonds.
Mirage.
Yes. The first application is how this concept is used to draw ray diagrams with prisms. So one case we have seen, two cases we have seen prisms.
Yes, sir.
So these prisms all are right-angled isosceles prisms. The importance of the first, second, and third all of them have critical angle 42 degree.
Okay.
Yes, sir.
So what is the angle of incidence here? Any idea at this point?
45.
45. What's the critical angle I told you?
42.
42.
So what happened for the light ray reaching there?
Total internal
Internal reflection.
That's why all the light rays coming down. The last question, they given different refractive indices for different colors. Okay, what we have done.
Yeah.
It's all same colors.
Sir.
So all of them will come. Okay.
Yes.
Yes, sir.
So if I have an object like this, like I have a candle or arrowhead, something like this here. How the image of this look like on seeing through the other face? The light rays coming here. The light from the top is coming here.
It would be.
Oh, so it would be like left towards.
It would be rotated like.
With the head towards
To the right.
left.
Head
Fine.
towards
270.
Head towards left.
Should be fine.
Yes, sir.
Yes.
The top head arrowhead will be here. The base will be here. So that means you can see the image 90 degree left, right?
Yes.
Yes, sir.
Yes, sir.
Okay, then if you keep the object here and see the light ray from the other side, the object is here.
Okay.
So it will turn 90 degree right.
Yes, sir.
Yes, sir.
So these type of prisms are used for turning the image by 90 degree left or right.
Okay.
Okay.
So where the light should fall on the prism? The light should fall normally on one of the isosceles side. See, not on the hypotenuse. The light is not coming here.
Yeah.
The light is falling normal to one of the.
Isosceles.
Isosceles side.
Okay, if the light is falling normal to the hypotenuse, see here, right extreme. The light is coming here. Still angle of incidence will be
45.
45.
45 because right angled isosceles prism, right? You want to check it's 45 or not?
So it is 45.
Yeah. So what's the critical angle?
42.
42.
So what happened to the light ray?
Total
Total
internal.
internal reflection.
With the angle of reflection, what angle?
45.
Yeah, incidence is 45, so reflection also 45. So total angle will be 90, right?
Yeah.
Yes, sir.
So what will be the angle of incidence here?
45.
45.
Yeah, 45. So again undergo TAR. One more 90-degree turn. It will come back here.
Yeah.
So the head will come as the bottom. The bottom will come as the head top.
Yeah.
That means the image will become upside down.
Yeah.
Yes, sir.
So how to get a light ray forming image inverted of the object?
Normal
the
to the
light ray
hypotenuse.
Yeah, fall on
So
the
the
line.
light ray should fall from the object normal to the hypotenuse side of the prism.
Yes, sir.
Okay. For 90-degree turn left or right?
It should fall on
To one
either
of
of
the
the sides.
isosceles sides.
Normal.
It should fall normally on one of the isosceles side of the prism.
Yes, sir.
The middle one, it's showing the light ray forming upside down image without deviating the light ray. It's going from left to right, it comes from left to right. But here it's going right and coming left. This is deviating. The first and last are showing deviation, right?
Yes, sir.
Deviation means it's supposed to go right, but it's come down, deviated. This is going right, but coming left, deviated. This is going right, coming out right. So we don't feel any deviation.
Yeah.
So here we can't have a calculation because the refractive index all we need. Like I told you, Nadi, we asked one question. It's easy to do this case. Why? Because light is coming normal.
Yes, sir.
Here you need to learn how to draw the diagram as it is because calculation is longer.
Okay.
So what you can do from this parallel light ray will come. The one falling here will be reflected and going to the top. The one coming from here will be reflected and see like it will become parallel.
Okay.
I mean this I'm not telling any explanation, demand calculation much.
Yes, sir.
Yes, sir.
So this is one application of total internal reflection known as reflecting prisms. Okay.
Yes, sir.
Yes, sir.
Explanation is given down. Now the second one is what Srinidhar told. It's called it's normally seen here in hot countries.
Oh,
Mirage.
Mirage.
Are you okay with the concept or?
Yes, sir.
Yes, sir.
Hot days, which part of the earth will be hotter? Near to the ground or above the ground?
Near the ground.
Near the
Near to
ground.
the ground.
The air become hot and expand.
And right.
Part of the air near the ground become a rarer medium.
Yes, sir.
Yes, sir.
So the light coming from the top of the trees coming through
Denser to rarer.
this part of the ground will be hot. The air will be hot, expanding, will be a rarer medium. The top air is much cooler, that will be denser medium. The light is coming from a denser medium to
Rarer medium.
rarer medium, and the density continuously changes.
Yeah.
Means if I take this is not this diagram I'm keeping, okay? I'm just doing another diagram here. This is one layer of the atmosphere. This is another layer of the atmosphere. So the diffractive index changes from layer to layer. There's no specific layers like this, okay? It's changing from here to here, 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 like. So imagine one light ray comes like this. one light ray comes like this. What happens on falling here? It's going from which medium to which medium?
Denser to
Denser
rarer.
to rarer.
So what will happen to the light ray?
It will move
Away
towards
from the
normal.
normal.
Away.
Away from the normal.
Yes, okay, away.
Normal.
So instead of going straight, it will bend away from the normal, right?
Yes,
Yeah.
sir.
Yes, sir.
Yes. Sir.
Sure.
Yes, sir.
Again, if it's going from denser to next rarer medium, like
Again, it'll move away.
yeah,
Away.
again it will move away. So it will happen. You can see here angle of incidence is less, right?
Yes, sir.
Here angle of incidence is more, right?
Yes, sir. Or
Yes,
finally
sir.
reach the critical angle.
Now it's not critical angle. It will go like this every refraction. It will bend away.
Finally,
Yeah, at one particular point,
it'll be critical angle.
it will be greater than the critical angle. Like, see now you can see the angle is much more. Like
Yes, sir.
this one, if you check, this one, the normal if I draw, you can see this much larger angle. Like see, this is very small angle, little greater. This much larger. So this may be the angle greater than the critical angle. So what will happen to the light ray from here? From here it undergo
Internal reflection.
Internal reflection.
total internal reflection. So it won't happen so bending. It's a gradual change. That's why they shown every layer is changing. Like then, if this reach the person's eye, so always the eye will get the image to be just behind of the incident light ray. To retrace the light ray received by the observer. Like the image carrying the top of the tree will reach in such a way the person will feel the trees below the ground.
Yes,
And
sir.
when you see things below the ground upside down, the mind already know, the brain already have seen in water or glass. So anyway, there's no possibility of glass on the road or what. So it will feel like there's a water present, and because of the water, it give you the reflected image. And
Yes,
even the atmosphere density slightly keep on changing, so the image will create a fluctuation like water vibrating. Image will be vibrating.
Yes, sir.
So you feel the presence of water on desert. Like
Yes, sir.
examination point of view, the first point is it is based on total internal reflection. Number one. Number two, the diagram. Number two, you should say light is coming from a denser medium to
Rarer medium.
Rarer.
continuously decreasing refractive index. So the light undergo refraction, bend away from the normal at a particular layer, it undergo TIR. The reflected light reaching the observer will create inverted image, making the feeling of pool of water. Okay.
Yes, sir.
It's fine.
Yes, sir.
Number three is called optical fiber.
Yes, sir.
Yeah. Someone told something I didn't hear properly. Divya?
No, sir. I didn't.
For an optical fiber, I think you've seen the optical fiber, right?
Yes, we learned it in 7th or something. I'm not sure.
No, did you see any flower vase? It's a decorating flower vase actually. You have a source of light on the bottom, and there's so many thread-like transparent pieces. And on the top, you can see light coming out from the edges. Did you see any decorating? I've seen one like this, but I'm asking, maybe not clearly.
Is it the one like that looks like a thread thing, like a big
Yeah,
brush thing?
brush type of thread so long, and the light just comes out from the top.
The tip of it.
Sir, I have it.
Correct.
Can I
Correct.
show?
Yeah, you can show.
1 minute.
Share it and show.
Wow.
I had one, but I don't know where it is. I have to find it out.
Sir, for some reason the light is not coming.
It's fine.
Can't see. Can you share? Okay, it's the same item actually. Is it switched on?
Sir, it's not coming. The light's not coming.
Yeah, is it switched on?
Yes, sir. I think the battery is dead.
Can you just hold all the string together and show? All the strings together. Yeah. Just keep it straight to the screen. Perpendicular to the screen. The edge should be. Okay.
Turn again.
Okay, anyway, it's not lighting up. No use.
No.
Thank you. I have something, but I will find it out. Where is it? The optical fiber is very thin, very thin. It's not that much like the diagram show. By construction, it has two parts. One is called core, the central part, and the outside part is called cladding. The cladding has low refractive index compared to the core. So the light is incident on the optical fiber in such a way, the angle of incidence is greater than the critical angle. Who has high refractive index?
Sir, I got it.
Yeah. Okay.
But,
Yes.
sir, later or now?
You can show it, fine, no issues. Share the screen.
Sir, it went. Okay.
So next class, we keep it ready and show us when we come.
Oh,
Okay?
wait. Sir, wait. Got it.
I can't see. Yeah.
Oh.
See that? That's why I told you, keep all the edges together. Just collect all the top together and show the edge. Yeah. Just turn towards the screen. The edge. Yeah, that's it. Yes, correct.
Oh, okay.
So you can't see the light passing through this in between part. Divya, can you show the central part of that? Yeah. You can't see the light from there. It's transparent. Still you can't see.
Oh.
Why?
It's transparent, but light will not come out because of light is undergoing TIR and passing through the tube and comes out from the top.
Okay.
So it's like as if the light is passing through a coated cylinder.
Yeah. It's not any coated cylinder, but the cylinder you feel is not like a pipe, okay?
Okay.
Pipe means centrally nothing, right?
Yes, sir.
You know chemistry, glass rod?
Yes.
Yeah, it's completely filled as a cylinder, like.
Yes.
So normally when we say there is a wrong feeling, optical fiber have centrally hollow. No. The central part is glass.
Okay.
It's not glass, it's called fiber, okay?
Okay.
Yes, sir.
Then outer part also separate covering. That is of low refractive index. So making sure light is going from denser to rarer. And since it's very thin, the angle of incidence will be very large actually.
Okay.
So the light undergo multiple TIR inside, like, and comes from the other side without much loss.
Yes, sir.
So the basic problem with optical fiber, as the light is passing through a glassy or fiber medium, light get absorbed. Like a lens, you remember? Lens light passes, the lens absorb the light. Mirror will not absorb light much.
Yes, sir.
So now the research is going on to find a medium which don't absorb light. Means the other side will get almost the same intensity. Otherwise, what you have to do, optical fiber have to be broken, and you have to use some amplifiers, light amplifiers, whenever the light intensity become less.
Okay.
So what's the use of optical fiber?
Transmission.
Transmission of channels, right? It is a complete channel, telephone communication,
Okay.
the TV communication, the internet broadband, all works on what? Optical fiber. So what they do, they convert electrical signals into light.
Okay.
Means if I'm speaking in front of a microphone, the microphone convert speech into current, you know.
Yes.
Yes, sir.
That current is passed through an LED, light emitting diode bulb.
Yeah.
So when you speak, as per your speech, the current will increase, decrease. When that is given to a bulb also produce increasing, decreasing light. That will pass through the optical fiber. On the other side, there's a device which can convert light back into what? Electricity, called photodiode. That we'll learn later. Okay.
Okay.
That will convert light into current. Then the loudspeaker will convert light current again back to what? Sound. So you don't want to learn that all. You should know optical fiber is based on total internal reflection.
Okay.
And what's the structure? Structure.
Core and
Core
Cladding.
and cladding.
cladding.
What's the
Core is
importance
made-
of core and cladding? Core is of
Core
Higher
is
refractive
Higher
index.
refractive index.
Higher optical
And-
density, which is glass.
okay,
Which
and
is
outer one
And
is of. Yeah.
Lower
Refractive index.
reflective.
That means if light is given to the core, it always go from what? Denser to rarer and undergo TIR.
Yes, sir.
So it reaches the other side without much loss. Then the uses of the optical fiber. The diagram is needed. Okay, any one diagram to understand the working.
Okay, sir.
One use is signal communication, like the second use is medical examination. They will send the optical fiber through the digestive tract. Half of the fiber will carry light inside. It illuminate the organ. Then from that reflected light will be taken half of the fibers, and computer can show the picture of the internal organs.
So endoscopy.
Yeah, endoscopy, correct. It's fine.
Yes, sir.
So,
Okay. And the last one of application of total internal reflection. Any idea how the diamond show brilliance? Sparkling
Total internal reflection.
reflections examination point of view, good half mark. Then the importance of diamond, it is a hardest substance.
yes, sir.
It is having very high refractive index. Water is 1.33, glass is 1.5, but the diamond refractive index is 2.4. So if the refractive index is very high, what about the critical angle?
Low.
Lower.
Yeah, very low. So it's coming to be calculated as 23 degree almost.
Okay.
Okay.
So what's the meaning of critical angle 23 degree?
When the incident.
If it's greater than 23.
Yeah, if this is surface and the light falling on this, okay, this is inside the diamond and this air, okay, this part is air, lower part is the diamond and this is a normal. So this light ray trying to go out, what's the angle of incidence here? The lower part is the angle of incidence.
Okay.
If the angle of incidence is 23 degree, what will happen?
It will go along the surface.
Yeah, it will go along the surface. Right, like this. If the angle of incidence is greater than critical angle, what will happen?
Reflect.
It will reflect internally.
It will
TIR.
reflect back into the diamond.
Yes, sir.
So if the angle of incidence is only 23 or less than 23, so the light ray is coming like this.
It will
Refract.
Yeah, that only will go out of the diamond. So this light ray, this much light ray only will go out of the diamond. The rest, how much angle here?
Okay.
This is 23.
That is 23.
Yeah, 23 only will be going out of the diamond.
So 67.
67 range of complete light ray will be reflected back to the diamond itself.
Yes, sir.
Means once light enter diamond, it gets trapped inside. It undergo multiple TIR and comes out through certain corners with what? The cone of the angle to be 23 degree around the normal. So it will create a sparkling effect on this point. Like.
Okay.
See, it depends upon the expert of the person who is cutting the diamond. The side should be cut in proper way so that most of the light undergo
TIR.
multiple TIR inside instead of escaping. Escape through certain corners with that 23 degree angle only. I don't know if you've seen the advertisement at least for direct diamond in darkness. It's showing certain sparkling effect, different angle you show. Coming from one point spreading out like.
Yes, sir.
I don't know, it's fine.
Yes.
Fine.
Yes, sir.
Important point, as Sakshi told, number one is it's based on total internal reflection. Then you should say diamond has refractive index very high, 2.4. So the critical angle is very low, 23. So most of the light once enter the diamond will undergo
TIR.
TIR and a very few with cone, 23 degree cone around the central one that only comes out through points, certain points. Those light coming out from the diamond will produce the sparkling or the brilliance of the diamond.
So the lines that come out of the diamond that get refracted are the ones that produce sparkling, right?
Yeah, this one, but comes out only.
Okay.
And this blue cone, no, only through that it comes out. The
Okay.
rest all will come back to the diamond itself again. So here the red color, you can see this, the color, red color. This red color is out of the blue cone. That is reflected back here. If it comes like this, it will be refracted out, like come through this blue cone. All other light rays, see this set 23, 67 here. 67 degree will be reflected back to the diamond. This is not a correct cutting of the diamond, okay? It cut here and again. Most the sides are cut so many different angles. It's the quality of the cutter, the sharpness of the brilliance will be more like, not the quality of the diamond itself.
Okay, sir.
So any doubt regarding TIR? These four applications are direct questions as it is from the note. But the other two what I discussed is questions based on that. The prism, 3 color of light,
Okay,
and
sir.
the area through which light comes out. These are the normal questions asked on this side. You want a break, 2 minutes to stretch out?
Yes, sir.
Because today I felt more because we had session with school. After that, I can't move my head. I can't check left and right like eyes are failing because we're not used to this now.
Yes, sir.
You people are fine. You use devices so much. I don't know.
No, sir.
Okay, now
Not
it's for
this
3.
much, sir.
For 3 with respect to the laptop. For 5 will come back. Not that much time. You don't go away. You can just sit, stretch, whatever.
Okay.
What or something. For 5 to Are you back?
Yes, sir.
So can I move to the next session then? Next topic.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
See, so far we have done the important derivations are 7. The 3 mirror formula, 3 lens formula, and the one with the TIR we did just now. It's not a derivation big, it's a small topic, but it's important still.
Yes, ma'am.
These applications all can come as 1 mark, 2 mark questions. Okay.
Okay, sir.
Yes,
Now
sir.
the next big question coming with respect to refraction again. Refraction through prism, refraction through spherical surface, lens makers formula, all it comes. Okay. Next one is refraction through prism. How the light bend when travel from rarer to denser, denser to rarer. Can you repeat once more?
When
Rarer to denser
it goes away,
towards the normal and denser to rarer away.
rarer is away from the norm.
So I'm just drawing the diagram once more. What is on the left hand side? It's better you have a pen pencil. You can try because this will be troubling you otherwise. How to get the angle, how to get the light ray and all proper. Okay. I think it's better I go to paint. That's good. This is hard to draw the diagram. So the top point A, the left down point is B.
So we cannot see the paint.
Okay, thank you. Fine.
Yes, sir.
Yes, sir.
So for me it's visible. So if it's not happening, you tell me because I'm in my world, not your point of view.
Okay, sir.
So the first A is the apex angle.